Alright, I've got exams coming up for, well, one of the modules in my university course is called Data Structures and Algorithms, and so I thought I would try implementing some data structures and algorithms in C++, because then that'd be good practice to, first of all, understand how the algorithms work and how the data structures work, and I don't know why I said first of all, that's literally it. Yeah, so I'd implement these like a library, I guess, and you know, because that's just a good way to make sure like they're robust, and I guess helps with like library design as well. That could be good. I won't worry too much about like error handling, stuff like that. I'll kind of just ignore that. But like to get the actual algorithms working is the most important thing, and I'll also do time complexity analysis because that can be quite important. There's also space complexity, which could be worth doing, maybe, and also I want to also do like actual what do you call it benchmarking. That's right. I want to do benchmarking and see how that works. I've also thought about doing unit testing, but I might skip that because first of all, support for unit testing in C++ isn't great, and it's also not really necessary because I can just make an application that tests a library anyway, and then just run that in my own custom way, which I'll do. Yeah. So anyway, that's the plan. Why C++? I'm doing so for context. Now, first of all, the exam is completely multiple choice, but since we're also learning Java in my semester right now, in a different course, different module rather. We actually have had some practice implementing these algorithms in Java. So you might be wondering, why not do Java? Well, Java kind of sucks, first of all. You know, grass is green. But also, Java makes it really unclear what's a reference and what's a copy, right? Like, structs are copied, whereas classes are referenced, or at least for C# that's the case. For Java, maybe it's different. And I just can't be arsed to, like, you know, implement a linked list like previous dots next dots next. Like, what? Like, I'd rather just like actually work with pointers and references. So I could just, you know, like I want a low level language to do low level algorithms, right? Because I will be working on like arrays and stuff. So that's the plan there. Now then the question is, why C++? Why not like C or Rust or Zig even? Now Zig does sound interesting, I was saying, but it's a language I haven't tried using yet, and I don't want to start now because my exam's coming up, and I kind of just want to get straight into implementing it. Rust, I don't want to do Rust because of the safety stuff, because again, like I don't care about safety in this case. I kind of just want to implement the algorithms, and I know that although Rust is a systems language and can get very low level, some of these safety restricts how easily you can get low level with like raw pointers and stuff. So I do that's like that kind of friction makes me just not care about using Rust at this point. Plus I don't really want to use any of like the like enums and like the result types, because again I'm not caring about error handling, so those kind of commodities are not very useful right now. And C, I don't understand why anyone would ever use C. Like I get using C for like a big project like Linux. Like with the Linux kernel, the main reason to not use C++ is just so that people don't write bad C++. But if you're a solo developer and you know what you're doing, there's literally no reason to use C over C++. Like you can write C style in C++, and even then, why? Like, why? Like, yeah, it's just kind of inconvenient. So, yeah, that's why I'm using C++. Anyway, enough of that. Let's go. So first of all, I don't know if I've already made something like this. Like a while ago, well, when I first started my course. Ooh, I'm lagging like crazy. Okay, let me save this. Yeah, my thing's really lagging right now. Not sure why. Usually it doesn't lag like this. What's open? Alright, so I got my C++ library here. Just close that. Save. That's not save. Okay, close. 5? Obsidian. Let's just close that for now. Claude. That can be open. What's my sec? No, nothing's there. What? Okay, I don't know what's going on. Yeah, I don't know why my thing's lagging so bad, but anyway. Right, let me share my screen. Okay, there we go. So yeah, so I do have 82 repositories, and a few of these are algorithms. Like if I search here, algorithm, you'll see that I have algorithm, C++, assembly, and Rust. So this was back in February, roughly when I began my semester 2 courses. This is after the Christmas break, and yeah, I kind of just made these to experiment with algorithms. Now I did Rust. What did I do in Rust? This was back when I was first learning Rust as well. In fact, this might have been my first Rust project, potentially, that I put on GitHub. But you can see, I mean, it's very simple. Like, I did a min-max algorithm. I said min-max, no, it's like min and max algorithm. To find the min and find the max. Yeah. Nothing too crazy. I mean, first of all, it just looks fucked. Like, what? Array split first. Okay, rest iter enumerate folds the first 0. Like, what the fuck? What even is this? You know? What is this? Anonymous function. Yeah, this is just a nightmare. Am I tripping? It's not recursive, is it? No. Yes? No. Okay, iter.enumerate. Enumerate? Enumerate just means like, what? Then folding first 0. So the first is like the first element. 0 is the index. Okay, I see how this works. It's just really fucked. Man, functional programming, I know it's like, it's useful. Well, useful. I know it's cool and all, but the, what do you call it? The cognitive overhead is just ridiculous. Anyway, that's why I did in Rust. Then in assembly, I think I did the same algorithm. Maybe another one? No, just those. Yeah. So I did find max, find min in assembly. I could use assembly for this project, but then I'll just be killing myself. So I don't want to do that. And then finally C and C++, which I think is just the best language to kind of practice these things. Which is interesting. I mean, again, like Zig could be a contender, but it is interesting that Rust is so not great for that. Here I did bubble sort, insertion sort, and linked list. Cool. So let's have like a bubble sort. That one I did in C. I did in C just like to kind of experiment with, you know, like using C without the C++ overhead and see like what that would be like. And you know, it's something. I mean, like it's just like using C++, but just less convenient. So anyway, that's interesting. Insertion sort I did as well. I can't actually remember how this one works, so that would be good to revisit. And also links list, yeah, which is C++. So the idea again is like I want to, yeah, is this functional? I mean, I read this one like mid lecture, and I think it's functional. But anyway, I also want to really like use, what do you call it? Documentation. I want to also like go ham on documentation here to kind of explain the process, like to explain my code. Now, of course, self-documenting code is ideal, but where I need to, or where I should, have stuff like time complexity analysis and stuff like that to like explain my thought process behind these algorithms. And yeah, that'd be good. So I'm gonna clone this project then. So let's just get the URL here. Okay, I think it's really lagging, and let's put it here, I guess. I still need to work out how to fix my workspaces with dual monitor, because I do have 2 monitors going right now. And yeah, so projects, what do we got? Okay, a new one called, well actually I'll just git clone first. So git clone, paste, Yep. Ooh, well, should I make a new project? You know what? I changed my mind. I'm gonna make a new project and archive the old one. So let's remove recursive, algorithms. Remove write protected regular file. Yeah. Okay. Okay. What? It's still there. Okay. For some reason there's protection on this thing. The Git folder. Don't know why that one has like write protection or something. Remove write protected regular file. Directory not empty. Huh? Okay, this is strange. It's empty. No, it's there. It's just hidden. I don't understand this. Remove write protected regular file. Yes. So now it's gone? If I... No, okay, now okay, now it's gone. I'm not sure what that was about. Something to look into later, I guess. But let's remove the directory. Yeah. By the way, for those who are unacquainted, I'm still getting used to using Linux in the first place, so I might have some hiccups here and there. Just got a phantom phone notification. The hell. Right. So I'm gonna make this. Call it algorithms and data structures. CPP. That's probably right. At the same time, let me pull up my actual course content. Now I can't leak my uni homepage stuff, but I can access this website because it's public. Very cool. So this is Comp 108. How did I misclick? Goddamn, it's called algorithms. Huh. I mean, now it's called data structures and algorithms, but okay. Yeah, anyway, so this was just gonna be like a breakdown of what I actually need to cover. I believe the content is more or less the same, and if it's not, then I'll see if I can spot that difference. But yeah, algorithms and data structures sounds good. Let's make that. Let's seed you into it then, and let's get in it. All right. So you got the Git folder. I'll create git ignore, I guess. Although I don't know what I would be ignoring in this case. I guess like the build files, right? Yeah. I need to set up CMake for this. So again, so I'm gonna be building this like a library. So I will get my other project up here. So okay, so I can compare how to do that, or like remember how to do that. So let's do. I think the binary library is probably the best set up here. Get CMake lists. Okay, that's hilarious. There you go. Honestly, well, I'm gonna not copy paste it just so I can kind of remind myself how this actually works, because like there is a rhyme and reason to making CMake things. So right, so we got the CMake minimum required. Just do 3.19, that's fine, don't really care. Project is going to be called algos and data structs. I think that's a valid name. Version, doesn't matter actually, just scrap that. Description, oh yeah, I need to update my binary library version actually. Not that it matters too much, because package managing isn't really a thing anyway, but description, implementation of some data structures and algorithms, right? Yep. In C++, that's fine. Set CMake, yes, for the standard, we'll just go for 26, I think. I do only use standard print and stuff, and I'm on Linux, so that's perfectly available on GCC. And hopefully it'll come to Windows soon enough anyway. Sources, nothing for now, but when they, oh, that's not, oh, what? Okay, never mind. Sources, I have none now, so I'll just add those later. Add library. Yeah, so we'll do library name. Now, is it not a thing to get the library name? Like a variable there. CMake library name variable or project name. Is that how you access it? Just like CMake project name, like that? Like, I don't think that's right though, is it? This is a project name. Huh? Okay, fine. So I think then just CMake, just change this to this. I don't actually know if this is a valid project name. Let me change this to underscores. And public library. Do I need that other stuff? Yeah, I do actually, I think. Builds interface. CMake current source directory / include. That's where I'll put it. Install interface include. Now, I guess do I want to make this a library? Maybe not actually. Maybe that's not the way to go. Okay, I'm gonna change my mind here. I'm not gonna actually do that. I'm gonna create a normal project. So let me quit out of this and see. Well, okay, I don't have any, but I do on GitHub. So, language C++. Remove the thing there. This one. Yeah, very simple. This is 3.28. Okay. I'm using 3.19 here. I guess I'll update it. I mean, again, like, it doesn't matter, but whatever. Right, so... right, so set CMake standard 26. Projects, yeah, okay. Algorithm structs, description, CCXX, that shouldn't matter. EXE linker flags. Right, so the EXE needs to include, like, the standard library. I guess I could do that. Like, yeah, like build a, like release on the GitHub, whatever. So let's do that then. Set CMake EXE linker flags. Yeah, so this is going to be GCC. So we're going to have static lib GCC and static lib, what's it? Standard C++. Okay. Man, how blessed are we to have such great build systems on C++. Way better than Linux. Okay, and then globe sources. Minus just a variable. So globe sources. Why is the annotation so messed up there? Yeah, so we're gonna have main.cpp obviously, and then we'll see what else comes after that, and then add executable, the project name, and the sources. That's it. Cool. So pretty straightforward, all things considered. Then we can quit, and we'll create our git ignore. So we're gonna go to a build folder, which is okay. So we'll create a git ignore here. .git ignore. We'll put builds, and let me actually check what I put here. Just copy that. License we'll do after. .vs code. Okay, that's it then. Yeah, I like IDE specific stuff. I can't remember what the JetBrains one is, but doesn't matter. I'm not using VS Code anyway, but just in case that ever tries to generate itself, I want to not have that add. Okay. And then a README can come later. That's also fine. And yeah, I think we're ready to get started. Oop. Scheiße. So I'll create a source folder, obviously. And I guess just do a test here. So let's open this in NeoVim. Let's get to the source folder. Right, I can't do that. Right, let's create a file, main.cpp. We'll do hashtag include. Now I can't use modules, but that's fine. Hashtag include print, because we're going to use that. Yep, standard print line. Hello world. Right, I'm gonna quit. Gonna make a build directory and cd into it, and then I'm gonna do cmake dot. There you go. So now the build files are there, so that we can cd out of this, and nothing else should be there. Okay, we've got cmake install.cmake, I guess, and cmake files. I'm in the wrong place. I'm still in the wrong place. Jesus Christ. Right, there we go. Yep, so nothing's there, and then we can just do cmake build. It's building the cpp file, and it's done. And then to run it, the target's called algos and data structs. Okay, let's cd into build. And I guess that's the executable, right? Algos and data structs. There's no extension, so I can't really tell, just straight off the bat, what it's meant to be. Okay, so we just do build, well, /build/ data algos and data structs, and just run that. Hello world. Okay, so we're now set up. Cool. Let's go ahead and push this, right? Initial commit, and then also get to GitHub. So yep, so let's add all the files and then commit init. Alright, so then we're going to get do we push now? Yeah, I guess we do. So we push now. No, I can't push because I don't have a thing yet. Okay, so we need to add it remotely. I never remember what the process is here, and I don't want to mess it up. But the first thing I can definitely do is GitHub repo create new repository, call it algorithms and data structures, CPP, KojoBailey, description, implementations of some algorithms and data structures in C++, public, readme, yes, git ignore, no, license, yes. We'll be using, this is not a library, so we'll be using the GNU. I doubt this is going to go crazy anyway, but just in case I magically find the cure to cancer, I'll make sure that's not stolen from me. Yes, clone, no. Nice, that's done. So if we go to GitHub, it should be there now. And our recent commits, there it is. Right, so now I need to push to there. So git remote. Yeah, so it's quite specific. Add origin. So okay, my history is coming in clutch here. So it's called data structures and algorithms cpp.git, and then we want to git pull origin main repository not found. Is it not meant to be .git? Let me try that again. No, it should be correct. I don't know why that didn't work. Must be missing something else. Data structures. Oh, it's algorithms and data structures. Ooh. Okay, that's the wrong name. So let me rename this. It should be the other way around. What the hell? Okay, screw it. Data structures and algorithms CPP. Rename. Okay, should be good now. Might even just work now if I git pull. Yep. You have divergent branches. I need to specify how to reconcile them. Yeah, so I need to do this properly. So git config global. So it's for future. I want to merge, if that's alright. So let's then pull again. Okay, done. List all. Everything's there. Got my license and stuff. Let's git push. GP. The current branch is no upstream branch to push the current branch, and okay, so git push origin main. Right. So now refresh. Everything should be there. That's right. Nice. And well, I can't say I did that without assistance because obviously I used my command history there to help me out. But anyway, let's give this some tags. CPP. C++, C++26. Doesn't even matter anyway. So algorithms, data structures, algorithms and data structures, oops, algorithms and data structures, and algorithms. Whoops. CMake. Learn by doing. Learning by doing as well is the one I usually use. Comp 108. Interesting. Well, it doesn't matter. Okay. Don't want to do too many tags, to be fair. Save that. Great. I like how if I get one invalid tag, it just completely just disallows everything else. That's really annoying. Try again then. Algorithms, data structures, algorithms and data structures and algorithms. Learning by doing. Save changes. Close that. And yep. Cool. The hell? Right, so I'm not gonna edit the README yet, but let's get started. So first things first. Well, I guess I'll go in order, right? So the first one I'm going to tackle is sequential search, right? The one that literally just goes through a list until it finds what it wants. Pretty straightforward, and then we'll do the technical complexity and whatnot. Best case 01, worst case ON. When you do technical complexity analysis, do you consider both the best and worst case, or just the worst case? I guess best case is worth considering. Like bogo sort, right, has a time complexity of O infinity, but in the best case scenario, it's O of 1. So in a scenario where O of 1 is impossible otherwise, it's actually quite efficient to run bogo sort in parallel with normal thing. The issue with bogo sort though is that bogo sort doesn't have a way of checking as well that they're in order, whereas other ones do, like confirm it. So bogo sort's kind of useless. Anyway, since I am actually doing this to revise my course, let's go through in order here. So pseudocode, right? Yeah, so an algorithm, you just give it an input, an algorithm into that. So an algorithm is a precise and concise set of instructions that guide you to solve a specific problem in a finite amount of time. So you give it an input and it produces an output, which is basically like a function, isn't it? Okay, so the difference between algorithms and programs. In algorithms, the content is more important than the form, whatever that means. Algorithms are free from grammatical rules, which means a program is written like in C++, right? Whereas an algorithm is applicable to any language. It's just how you implement it. And same thing there. Okay. Now, admittedly, whoa, wait, this is 2021. Admittedly, I don't even know that this is a good revision guide, but whatever. I mean, the alternative is going through the course slides, which I guess I should do. On that note, I'm just gonna skip this stuff and I just go straight to the algorithms. So let me just check here. Pseudocode 2, algorithm efficiency. Okay, so we're going for a sequential search for an array, and let's just start there. So neovim this up. We're going to create how should we do this then? So for each algorithm, I'll put it in a header. So I guess we'll start there. So for example, sequential search .http, right? And they'll simply contain unscoped functions. Makes sense. I could put it in a namespace, but like, no. I don't see the point in that, because it's a project. Yeah, no, that's fine. So let's do, well, let's first define our function. So we're going to call it sequential search, right? What's it returning? It's returning a T, right? So it's templated, first of all. Template type name T. Why does that look weird? Don't know why that looks weird to me. T sequential search, and it will take an array, right? Now in Rust I'd use type traits here, but in this case I can't do that. I'd like to use concepts though, because like I want this to work even for flipping linked lists and stuff. Like these algorithms should apply to any data structure as long as it has like a next and previous thing. But like then again, having it generic is probably not a good idea, because like there may be more efficient ways to maneuver different thingies. So yeah, let's just assume that this is for an array, right? So sequential search on an array. I could actually make an array class, couldn't I? It's not a bad idea. Like if you check the C++ array class, my assumption is that it comes with some functions already for like searching. Maybe. It also should inherit some things, right? Maybe, maybe not. Oh, whatever. Wait, what? Make array. Okay, so maybe I create a class then, an array class, a custom one, because that is obviously a data structure, and I should be practicing implementing those as well. And then I should do the algorithms. I should tie them to that. So in that case, new plan indeed. So let me go out of this. I don't think I saved it right, so that's fine. We're going to create an array.hpp. And we're going to, so class array with a capital A, just to differentiate it from standard library. Class array, and yeah, public methods, private stuff. Let's get to work. So the first thing is it's going to be a template. Right, template class type name T, array. Well, actually, it should be T and the hell, standard size T, N for the size, right? So it's an array of type T and size N. Yep. And then internally, it'll just be a pointer, right? So it'll be a pointer to some memory location on the stack. So it'll be a stack pointer. But when the array has a fixed size as well. Oh yeah, it's fixed size, so it's not dynamic. So that's fine. I could implement dynamic arrays later as well, but right, for now, I actually want to call this static array to differentiate it from a dynamic array. And yeah, so it would just contain a pointer. I'm gonna try to avoid using like standard library stuff, except for obviously like type, you know, like type things like size T. So I need to hashtag. I need to include C standard int for size T. But yeah, so we'll have a T pointer to the memory. I mean, I could use just. I should use the array syntax, right? I guess, but. I don't know actually. Alright, so it'll be T array of size N. Right? And it will default initialize. So the type needs to have a default initializer. I believe this works. And yeah, sounds right. Then you just initialize it with whatever thingy. So static array. So yeah, so public static array. Taking a. Well, it'd be multiple arguments, so I need to look at how to do that. But that's the constructor, right? Let's just test with like one thing here. So like we'll do a TA, and then for the implementation, well, that should be actually, yeah, no, we'll define that externally. And then we also need to define the operator overload. So operator overloading this operator. Sorry, it returns a T. So T operator. Not well. It could be T reference to be fair. Should I do reference? Or is that automatic? It might be automatic. I actually don't know. I'll come back to that later, I guess. But it'll be that. It will take in a T. No, sorry. It'll take in an index. Right? And then it will just return that. And yeah, let's go from there. So this is the HTTP file. We then need to obviously create a array.cpp and just have that include array.hpp, and yep, so static array. Well, yeah. So the constructor, I said, just takes a TA, right? Now I don't know if I need to specify what T is in this case. I probably, like, do I need to do that? I don't know how this works. I haven't really written a templated class before. I guess I did for the linked list, but maybe I didn't. Let's check. I just closed it. Let's get back up. There we go. I did. So that's the constructor there. That's how I do multiple thingies. Just args, template type args. Okay. Then I call append, right? So I'll do that later. But like, if I want to define it in an external file, do I need to just do the template thing? I guess we'll find out. Anyway, this will just add it to the array. So, ooh, it is of a fixed size, mind you. I wonder how that works. Anyway, so it'd be array, right? Like this dot array. Well, man, this language is so whack. Array at 0 equals a. That's it. And then for the operator, so the T operator, boom, 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 boom. Wait, no, sorry. If they're templated, you can't define them externally anyway. Yeah. So that's actually completely pointless. It means I have to do it there. Okay, that's funky. So in that case, still array 0 equals a, and I guess I should like not even bother having an external file then, array.cpp, because I can't do anything with it. Yes, delete that. Remove it from. Okay, I never added it. Operator plus operator thingy. Return array index. Right, so that should be enough to get started. So let's go to our main, hook it, make it first. Okay, includes array.hpp. Create a new static array with well, equals, I guess, and then give it the constructor. So we'll do like 5. Give it obviously information. So static array type int with size, let's just say like 10. Yep, that should work. And then we're going to standard print line array at index 0. And that should work, I guess. Right. So we'll create a new window here, terminal window, and go into the things. Nice. And let's just, yeah, see make build. Okay, to get error. Static array is not a class template. Right. So for this, what did I do? Okay, so you don't put the type information there, right? So the issue is I have this. We need to remove this, and the rest should work, I guess. I wonder if n would get picked up there. The syntax highlighting isn't registering it, but no, it does work. Okay. So I'm gonna change his names here. Array type and array size. It's probably fine. Or static array type, static array size. Just make it more like explicit. Or should I do them as like constants, like static array size? I guess I should. Like this. Okay, tell you what then, I'll do this. I'll just do type and size. So any of these t's will get replaced with type, and the n will be size. Okay, that should work. Let's compile. So why am I so slow? And then let's go ahead and run it. Yep, array 0 equals 5. So that works. So now we'll just replace these with these thingy, the args, whatever. So template, type name args. Yeah, dot 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 args. I don't know how you set a certain like a size constraint, but figure it out later, I guess. Args dot dot dots have the initial values. Yep, and then we'll just do this cool thing. Now, well, we're not calling append here. The hell? Okay, we're not doing append here. We need to call operator thingy. So yeah, this syntax is really funky, but basically you do this. In the right hand you do dot 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 to say like repeat the previous thing, and we'll call operator this with initial values, and that should work, I think. Don't know why that's the syntax, but that is the syntax, and that should work. Now we also want to have a restricted size, so C++ template args with specific size. Yeah, here we go. Variadic template. This might not be what I'm asking actually. Okay, C++ variadic template with fixed size. I guess you can static assert it, right? Like if I were to, I mean, first of all, I assume this compiles. Oh, for God's sake. Yeah, so that compiles. But I assume, let's try this. So let's do standard array, int 10, same thing. Array 2 equals, well, not 10, let's do like 2. But let's say it was like 1, 2, right? That works, I assume. To hashtag include print for, well, need to include array for that to work. So if we build that, should get no build errors. But if we try to give it more, right? What? More things here, like let's do 1, 2, 3. I assume I get some kind of like static assertion error. Okay, in function, int main, too many initializers for standard array. Like how is it giving such a specific error? Is that because it's like compiler defined as opposed to standard library? It must be. Like otherwise, how does the compiler do that? Too many initializers. Okay, I'm gonna actually pull up Claude for this one. Boom. Let's go. Oh, sorry, it's already opened. Good. Right. So how is standard array implemented to give such a detailed error like this? Hopefully it's not compiler defined. It shouldn't need to be compiler like specific. Oh, is that it? So it's just like a default constructor? No. Is the constructor implicit? I don't understand. Take this time. How does a compiler know to use data within the class? I really hope it isn't some compiler wizardry. That's weird. So for this to work, the internal data, right? Like here we have here I have array here, right, as private. But what Claude is saying is that this has to be public for it to work. But then if it's public, that means that the data is accessible when it shouldn't be. It should really be hidden. And that's kind of like a weird compromise that really shouldn't have to be a compromise, I don't think, but okay. Is there an alternative way then where the internal data can be private? God damn. God damn. Okay, fine. I guess we'll take a note out of the Standard Libraries books then, and just do this. Right. So we will give it an underscore to say that it should not be touched, and that is that. At this point, I can just make it a struct, but we'll see if we do anything else. Right. So now if I build this, will it still work? Yep. Nothing broke. Just delete this then. So now if I were to try and initialize this, I need to destroy this constructor. And this shouldn't work now. Didn't even save apparently. Oh, compiles. Okay. Let's make it 2 and say 5 1 3. Too many. Okay, so I can have too few but not too many. I wasn't aware of that. Yeah. Okay. I guess that's fine then. So that's cool. A little quirk of C++, I suppose. Right. So moving on then. Sorry, brain fart. Right. So we got the array there. We've got the access there. Right. So let's go ahead and add some. Okay. Well, first thing first. Let's add a print function. So print. Yeah, just print, I guess. That one actually can be implemented externally. Well, can it though? I don't know. I'll just do it internally. Screw it. Right. So for print, we want to I guess I should do this. So it's print this. Well, no, we want to use a string builder, don't we? So that's standard string output equals just empty string. Initialize that, and then output plus equals this. It's an array, right? So do this actually. And yep, for T okay, there needs to be a method, that's the thing, to convert it to a string, otherwise it won't work. Although I guess that goes without saying. Okay. Interesting. Okay, fine. So I'll do T elements, I guess, for the array. Output plus equals standard to string T, and then output plus equals comma space, but it shouldn't if it's the last element. So I'll also do an int, well, size standard size ti equals 0. This is the index, I++, and if I does not equal size -1, then do that. Okay, and then the end output plus equals closing brace there, and yeah, standard print line output should be good. So we need to include print, and we need to include string. Okay, let's see if this compiles. T was not declared in the scope. Alright, it's called type. Let's do auto. To string T. What? That should be LM. Okay, so if I go here now, let's have a static array of size 5, and just do 1, 2, 3, 4, 5 for now, and let's do, yep, array.print. Should print it. Oh boy. Call to const evaluated function is not a constant expression. Right, that's interesting. So even though it's a string, I still need to add this because it's because it's on compile time. Fair enough. So build that. At least it's consistent. Same with Rust. So right, that works then, and then yeah, just dot slash run that. 1 2 3 4 5. Perfect. So there's our printing. So that'll be useful for actually seeing our progress. We're an hour in, and we just got the array like basic working. So now we can do the actual algorithm, right? So we're going to do sequential search, which should return both the element and, well, no, actually just the index, because it's a search algorithm, right? So we're going to do this. So yeah, standard size, size t, sequential search. Give it a index. Now give it a thing to search for. So type, this will be target, and we'll also give it an index. So the index will represent if it wants to skip one, how many it will give, right? Or I could actually just have it actually return a I'll have it return 1. Like I could have return like an array of indices, but I'll just not do that. So size t, what do you call this? We're searching for a target, and we want to know which, what's the word? Which instance? Which index? No. Iteration. Okay, we'll do iteration, I guess, for now, until I think of a better name. So very simple. It would just do a simple for, well, not even that. Well, we should for int I equals 0. Well, I do want to use a range based loop. So we'll have our size t index equals 0 for auto elements in the array. We simply check if this actually has potential to give nothing. So actually I should include optional here as well. A B C D E F G H I J K L M N O P. Right, so this will actually be an optional IT size t. So standard optional size t. Yep. So if element equals target, I also do size t iteration here equals 0, and I'll do target iteration. Yeah. So if element equals target, then if iteration equals target iteration, then return index. Otherwise, iteration plus plus, and at the end I plus plus. Yep. And then if all else fails, then just return empty or standard null opt, whatever. Right. So that's that. Should work. So let's go head to our thing here, and we'll do a sequential search. So print line. I love print line, dude. It's just so convenient. Array dot sequential search, and give me the index of. Let me change these numbers around. Let's do pi 3.1452. That is awfully convenient that the first 5 digits of pi fall between 1 to 5, right? 3.1452 6. So the first 6 digits of pi are actually completely 3.14. Oh, it's 1.5. Never mind. Well, still though, they're within the range. 3.15, 3.1415, 9. Yeah. Okay, this actually works quite well for this purpose. So array dot sequential search will find, give me, I guess we should do all the digits, right? Just to kind of exhaust this. So I'll do 3. Also I'll give this an implicit thingy. Have it just be 0 by default. Default argument, sorry, is what I meant to say the first time. So we've got 3, 1. And then we'll do 1 again. But the first one, first or second one. Okay, to make this actually, yeah, 0 indexing. The 0th one and the first one. I guess it makes sense. It should just be funky, isn't it? And then give me 4. I don't know why I'm doing this so inefficiently. And give me 5. Okay. So let's compile. Okay, let's compile, please. It returns an optional. Whoops. Whoopsie daisy. Does optional not have a way to print it? Interesting. I actually thought that optional would have a way to print it, but I guess not. That's a shame. So in that case, let me actually also create a function to print optional specifically. I could even create my own optional class, couldn't I? Like it is a data structure, to be fair. So maybe I should create my own optional class to see how that also works. The issues are like I lose nothing, actually. Yeah, screw it. Let me also do my own optional class then, and then I could write my own formatter. In fact, let me do this differently. So I think I might have done this before. Print list. No, okay. Like there is a way to have it be accepted by the formatter. So how do I define? Actually, I'll just look in Google. C++ define custom formatter. Here we go. I hate this highlighting. Can we not do that, please? Google, please. Whatever. So template, formatter my type, parse. Is that what it's called? And then formats. Wait, what does parse do? That's okay. That's for debugging. Parse ctx.begin. Formats id.id. Because it's just an int. I see. Yeah, it makes sense. Okay, so let me copy this thing here. So it's this will be for the array class. It does confuse me that this isn't really built in. Like I think Rust has ways to print arrays, and I assume it has ways to also print maybe types, or option types rather they're called. Anyway, so template, boom boom. Well, this will be at the bottom, wouldn't it? I'd have to. So template, boom boom. Struct standard formatter. So I should include format as well, just to be explicit. Yeah, so standard formatter for my class StaticArray. Right, so struct and constexpr auto parse with standard formatter what? Parse context by reference CTX. So I need to. Why do I need to define this? Okay, must be some like flexibility thing, right? And then auto format cost, or maybe I don't, and I'm just following this bad tutorial. But to be fair, it was only the first option. Let me actually look for a different one from Stack Overflow. Yeah, okay, I don't. You can reuse standard string. What the hell? Alright, you can... Okay, these are outdated. Okay. Okay, yeah, it is interesting how you can just copy strings, but... Meh. Right, so static array reference, I guess object, why not? Then, yeah, format context, ctx again. I don't know why it's different than parse context. Oh, it's const apparently. Yeah, man, like, this versus Rust traits is just insane. Like, why? I mean, I know why it's so complex, but like, this language really needs to be replaced by a better one. All right, and then we enter the things there. Yeah, so we'll do this. That's fine. Well, actually, no, it's not fine. So, how does this work? I have a few options here. I'll just do it like this. So I'll do boom, 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 boom for the closing and opening, and then I'll do output there, or like the stir, I guess I'll just call it. And then I'm gonna take my code up here and just copy it. So let's go ahead and delete this section of it. That's all I need. Paste it there. Remove this. Replace output with stir. It'll be object.array. Size. Object.size. Can I access that? I assume I can't. Or maybe I can? Okay, this is too specific. If I have a templated class, can I access the template parameters externally? Like my object.t. That's fair. Okay, so using what? Okay, just using value type. So using value type equals, oops, t. But I wouldn't do. Surely, if like for the size, I can't do using, right? You know, I have to be a static const. Just expert. Size t size equals size, right? Surely. Okay, so then, I mean, I could just confirm this by looking it up, but I'll just leave it for now. So it'll be object colon size. Now that just seems wrong. But I guess it's not wrong. Static array size. That's better. Okay, and then that should work in theory. So then I do not need the print method anymore. If I want to print it, I'll just do it externally. So back here, instead of this, I'll just do standard print line like this, and then do array dot. Well, no, just array, and it should work. Now I could actually get rid of the brackets here, so then I can do custom brackets, but I'm not going to bother with that. Let's build. Let's see what error I get. Right, this will not work yet. So let me just disable that. Yeah, I would have been surprised if that worked. Using value type equals t. Jesus Christ, I am a bit slow. Type. Well, since I have type there, I will actually just use t. So I'm actually going to change this back to t and n, since I'm creating aliases for them anyway. Aliases, Jesus Christ. And I can use it here. So array size, that should work, because it's const expert. Unless it needs to be like const eval, but I don't think so. Bloody hell. Right, so change any type in all caps to value type. I didn't fix this bug yet. We got more though. God, dude, formatted errors are just so messy. Okay. Mismatch at argument 1 in template parameter list. Right. Is it because of this? It should be like tn. Okay. Oh, nice one. This one's Claude. So, static array is a templated class of static array tn. With that in mind, how do I define this properly? Right, yeah, so I put them here, do it here as well, okay, and then here as well, and then I can access those. Better than to string, handles more types. Okay, yeah, I thought so. It's weird that toString doesn't do that though, but I guess that's just the language, man, being old. So type name t. Now, okay, whatever. I'll just ignore that. Yeah. Let's not even mention it. So then parse is the same, right? Yeah, exact same. It's just here that I need to add the template things here, and then I can access them here. Now I could just decorate size, but let's just do n. That's so weird though. You know what? I do prefer decorate size. Keep it explicit, and then. Yeah, instead of just string, we use standard format, like so. This condensed it into one line, and also made it a range, a normal 4-base loop. Look, I just like range-based loops. I find them more, like I find this just more idiomatic to read. Like for each element in object.array, like okay, fair enough, right? I find that nicer. I could obviously condense this into one line, but I don't see the reason to. It just makes it harder to read. Let's build. Let's see what's up now. Has not been declared. Did you mean? Yeah, I probably did mean parse content. Format parse context. Format parse context. So this. To be fair, it's just object size. Objects are a class. Oh man. Okay, so I can't do that then. I mean, I can do type of, right? Type of object. Clinical and size. That works. Unexpected primary expression before type of. What? What's wrong with that? Fine. Fuck it. I'll just do n-1. But like, why? Why did that work? Okay, can we chill out, please? Oh, declare type. Right. Okay, fair enough. Okay, that seems to work. I'll use tickle type anyway. Object, clone size. What's going on here? Okay, can I stop misclicking? What's wrong? Line 8 of array, okay. Not a constant expression. Literally, how's that not a constant expression? Size is not a member of const static array int 5. Yes, it is. It's right there. Bro, what? Const eval? I don't understand. Size is not a member of const static array. What? Bro, I don't understand this at all. What about for a size? Yeah, that's what I did. But it says size is not a member of const static array int 5 reference. Even though it literally is. Alright then, fine. We'll just do n. Some funky things going on here. So I don't understand what this error is saying. Let me just check this again. Close output. You're calling it but not returning it. Whoops. Genuine misclick. Oh my god, how do I? That's right. Okay, that wasn't indeed the error. So now it prints, awesome. And now I need to do the same for an optional class. So let's go ahead and create that then. Optional, well actually I can call whatever I want. In fact, this should be called something else. This should be called StaticArray.hpp. And this should include that. right? We can remove print now from this. I don't think we need it. Mind you, I think we do need it, because now this should not include that. So let's delete that. Here, hook that, delete print from there. We'll delete optional as well, because we're not going to use it. We're going to use my own custom one. Format we do need, string we do not need explicitly, because we're not using to string. Well, we are using string, I guess, but it's included in format. I don't care. I guess I should care though, because I'm doing string building. What? There we go. Right. Compile. Okay, so that works. It does work. Nothing wrong. Okay, so let me go ahead and just commit this then. So git add all, git commit, create static array class with printing with format with sequential search and format compatibility. Weird English language, man. Push that. Okay, fine. Git push set upstream origin main. Made a typo. Okay, so it should be there now. Yeah, looks right. 4 commits. Okay, so that's cool. This is very insightful. I'm glad I chose to do this in C++ no less, because it's a funky language. So stuff like this helps you learn it better. Right then, let's create an optional type. So what do I name this? In Rust, it's called option. In C++, it's called optional. In Haskell, it's called maybe. Then again, in Haskell, it's called either for the result type. Whoa. I guess optional makes sense. An array class, an optional class, a maybe nothing, optionally int. Okay, that's what I'm just gonna call optional. I think the standard library team for C++, Jesus Christ, I think the STL team cooked for that one, that naming. So we will be including format, just a little heads up there, I guess, but it'll be a template type name T once again for a class called optional. And it would just well, using type name was T. There's more to it, right? Value type. That's a convention, I guess. Yeah, okay. And then we don't need a constructor for that. That's fine. Yeah? Yeah? Ooh. No. Because again, it could be nothing, right? Oh, this is weird. Okay. I mean, whatever. So, first of all, we have T, right? So T, or value type, value. be underscored value. Actually, this one can be private, I think. And this should be public. Just a little FYI. So value type value. I guess I underscore it by convention. I don't know. I'll underscore it. So value default initializer, and then we have a bool for whether it's active or not. So is active. Has value. Which is false by default. Okay. Yeah. Yeah, that's fine. Okay, so then we have our things, right? Like operator star, the dereferencing thing. Now, I mean, yeah, do I even want to use this? Not really. Yeah, I'm not a huge fan of the star syntax. I'm just going to do a function. So we'll do void, no, t, right? So value type is return type, value. And this will throw if empty. So you should only do it if it's actually something. So boom boom, bada bing. Right. So if not has value, then throw I just don't know. Let's have a look at standard optional. Exception. Bad optional access. How do you create a custom exception? So you just derive from runtime error. Okay. Okay. Thanks to this guy. So we'll have this here then. I have done this in Java, like custom exceptions. So I'm just wondering how similar it is in C++. So, I mean, in this one it's called. Did I close it? But what's my problem with closing stuff? Again, I just went back. Bad optional access. Yeah, so just let's call it invalid optional access, or like empty optional access. Well, like try to access optional when it was empty. Yeah, so empty optional access derives from standard runtime error. Is that right? Publicly. Yep. And oops, creates a standard string. Oops. I don't know what runtime error falls under. standard accept. That's right. So include standard accept. Yep, it's the message. I guess that's private. Const char, so it's a pointer, not a string. What const override. Return message dot c string. Okay, and then I can just write it there, right? I assume. So yeah, just have this a const. In fact, I can even just do a const char, can't I? Because like it's embedded into memory. So I'll do const string view, const expr string view, and just have it be tried to access optional value when object was empty. Something like that. So if I try to compile this to CMake, see what it makes of it. Okay, doesn't seem to care. Maybe because I'm not using it. Although it should still compile. It's a header file, right? I'm not including it. Let's include. Well, it'll be used by StaticArray here. So we hash include here. Include optional dot HPP. Now build. C string doesn't exist in this context. In fact, string viewed isn't declared. Non-static. Okay, so it needs to be static as well. So let's go back. Static. Include string view. Does string view not have a cstring method? Okay. String view. Holy typo. Basic string view. Data. Okay. Sure. What's wrong? Says expected a semicolon. Oh. Oh, right. So throw empty optional access. That's how that works. How do you throw in C++? Throw plus exception. In Java, it's like throw new. I don't know if we need to do new for C++ though. You don't. Okay. So I should be able to just throw it then. Oh, I just construct it as well. Just like this. Because it's an empty constructor. Right. Looser exception specification on overriding virtual function. Const what? No accept. Is it meant to be no accept? Okay. That's fine, I think. Like the order of that is whatever. And then expected semicolon on 32. Right. Okay, but that works, right? Sick. That's my okay. Well, that's my first time doing a custom exception in C++. And then yeah. So if it doesn't, it throws. If it does, then it simply returns value. But value should probably return a reference. Right. Yeah, this is weird. Yeah, I'll do reference, and then if you yeah. So it returns a reference value, like as a reference. In fact, I'll do this. And then what happens is that if you want to copy it, then you just don't. Well, then you just copy it. That should work. So that works. Okay. We of course need it is empty, right? So bool is empty. Just a getter. What the hell? Return has value. Yep. And I will do an overload here. So operator, well again, bool operator exclamation mark. Do I need to say this? I want to say I don't need to, but maybe I do. Whatever. But it was return is empty. See how that works. Oh shit. Sick. That does work. So bool, make this no discard. Value is const as well, and should also be no discard. Okay, let me actually also do this here. That's fine. Operator should be no discard. It's also const. Sequential search is also no discard because it doesn't do anything else. And it is indeed const. It should be anyway. I'll just add const here as well. Const auto element array. That should work. Let's compile. Nice. So we'll do git add. StaticArray. Right, and let's push, well, we'll commit that one, so add no discard and const qualifications, whatever, and just push that. Okay. What's going on? Did my screen like that? But okay. Yep. So this works. We also need to have the constructors. So optional T. I actually don't know how you write constructors for this. How do you write constructors for these things? God damn it. Misclick. Yeah, you do have to do. No, you don't. No, you don't. Okay, fine. So optional value type. Okay. Yeah, so if it takes one, then it does it. If it doesn't take one, then it doesn't do it. Sick. So value type will just be what do I call this? Value? I mean, actually I can't call it value, can I? So value value equals value. Pretty simple. In fact, to that extent, I can just do value wraps value like that. And then also have the other constructor, which is just default. Well, actually, it just does nothing. I don't know if that's optional. Like, if I do default, it might actually mess around with something else. So I'll just do that. If it's optional, then actually, if it's optional, like this, then has value is false. For this, we say has value equals true. And that's const. Well, no, it's not const because you can change it. That's fine. I do have this here. So one could argue I don't need this here. But it just makes it like explicit. So I'll just... Well, but like, is it less efficient? It probably is, isn't it? In that case, yeah, fine. Right. No, don't do that. CMake builds. Nice, microstructures are behaving. And cool. So here, I guess optional is included in one of these other libraries, which is why it's valid. But let's go ahead and replace, whoops, let's replace that with optional, my own custom class. And that should work straight up actually. Because it just constructs it in this case. Right? Nice. Sick. Okay. So this works. Supposedly. Let's test it here. We'll do sequential search dot value. No. Okay. Right. So user deleted function. Okay, so I have a mistake with my custom thing here. Let me just give it to Claude because I think the documentation I found online might be outdated. Is something wrong with how this class is defined? The constructor. Oh. So I don't need what? What? Okay. I guess just proves that it ain't so bad to check, to ask Claude instead of asking Stack Overflow from 6 years ago. I wonder if this is a new thing or what. But okay then, fine. So we'll just create constructor. My thing is frozen. What the hell? Don't know what just happened there. Empty, optional access. Can I make this a struct? I assume that's valid because it's like no difference. Ah, screw it. Right. Empty optional access because it's not a struct, not really. Because it's deriving from a class. Standard runtime error. In fact, it might even be invalid, but I'm not going to find out right now. Okay. Yeah. That should work then. Discards qualifiers. Where's this? On line 10? No. That's there. Line 40. What's wrong? Is it not const? Is that why? No, it isn't. Binding reference of type. Discards qualifiers const. Oh, good point. Yeah, good point. Okay. So should I create a different function for value ref? I feel like it's just unnecessary. Okay. I'm gonna keep it like this for now. The hell? Let's run this. 0. That's correct. In fact, it's almost 2 correct. Let me just change this to like 4, so I get a more interesting value. Two. I got a comment on my Instagram post, my latest one, from London UK official, telling me to send them the post, but like I'm not even in London, so okay. Unless like I put the wrong location. I said Liverpool, so I don't know why it's doing that. Anyway, so that works. Cool. And I do want to test this real quick. So right, so if I take a reference here, right? So let's say I create an optional int foo whatever, which is just 1 equals 5, and then auto. So first we'll do auto ref. So we'll do 01 ref. Okay, maybe just op. So op ref equals op.value. Okay, and auto op copy equals op.value. Now the only difference here is the use of auto with this and auto without this, the reference thingy. So I wonder with this copy. So let's go ahead and print line. Okay, so actually first thing. So this should be int, just to make it more explicit. So well, let me try with auto too, because I want to test something. So we'll do op ref plus equals 3, and then op copy plus equals 3, and then we're going to print line. We have ref, and copy. So op ref, op copy. That should print their values there. And let's have a look at what happens. I should really create like a build command shortcut, like CB or something. That's terrible. And let's run it. Right. So in this case, they both got changed. But is that because auto became int reference? If I do explicitly just int, will that make a difference? I'm wondering. Sorry. This is dumb. This is so fucking stupid. If you caught that. Yeah, that's just dumb. So we'll do op 1 and then op 2. This one will go from op 1, and this one will go from op 2. And then we're going to print op1.value, right? And then op2.value. So the test here is, was the copy separate, right? Okay, so we're going to see make build, and then we're going to run this. Nice, yeah. So here, because I didn't use the reference thingy, and now I'll change to int, because it does print out it is equivalent. It is equivalent. So let me build that. Okay. Yeah. So notice, right? So here, because I did not, so here because I used a reference and value returns a reference, it gave me a reference, right? Fair enough. So if I increase the reference, then that affects op1, right? But here for op copy, even though value returns a reference, int, because I'm not taking an int reference, I am implicitly creating a copy of the int. So then if I increase the copy, it does not affect the value inside. So that's perfect. That's exactly what I want to happen there. So cool. We can go ahead and build that. That is working as intended. So let's go ahead and git add all, commit, create optional class, push that, and then also here I need to make sure that this returns a value type reference to index, so that if you want to, you can take a reference to the array element, but if you don't want to, it'll do a copy, and that is important there. Okay, so again, git add all, make static array boom, return a reference which can optionally be copied. Right, that makes sense to me. So now we just need to make a formatter, because this will still not compile, right? So let's go ahead and do that then. So we'll actually just copy this because it's already kind of written by me, and we'll paste it at the end of this file. The difference here is that we just have type name t, we're doing optional t, and same thing here. Okay, this doesn't matter. We can just return. Well, okay, so we'll do if object dot, so if it's empty, then return standard format to ctx dot out empty. Otherwise, return object dot value. But really, it's just like optional, right? So let's do like optional colon, and then have these. That should work, hopefully. And then optional colon empty. That's the best way I can think of to represent it. So let's build that, see what happens. What's wrong? This argument discards qualifiers. What qualifiers? Because values are const? Yeah, see, this is the issue, right? I can't do dot value in a const context, even though it should, in theory, be const. That's really annoying. I mean, I kind of just remove the const here, I guess. Or like create like a separate method called like const value. Value const. So like you cannot copy it. This is weird. Okay, I will do it, and I will see as well what the idiomatic way to do it actually is. So value copy. Okay, I'll call it value copy for now. It'll do this, and then for this one, same thing. Just trying to think if I can combine these into one logic. Yeah. Return value. This is const. But value's not const, so it won't work. Fine. Right, so we have that. Then down here, I'll do value copy. that works. And then here, optional empty, 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 empty. Well, that's not correct, but okay. Is empty not has value? Not yeah. In fact, I'm actually gonna remove the not operator just for now because I don't really like it. So cmake build. Okay, try again. Okay. Holy voice crack. It didn't seem to actually put the thing there. I don't know why. Okay, now I know why. And to escape these, I guess. Bro. Ah! Backslash, right. Yeah. Great. How do I include these without C++ braces in format? Normal curly braces. Okay, fine. How for C++ format strings, how do I include curly braces / brackets? Curly braces. Curly braces normally without. Okay, well, how do I escape curly braces? Double. Oh, holy shit. Okay, so boom, boom, boom. I need triple in this case. Now it works. 0, 1, 3, 2, 4. Perfect. So let's go ahead and commit that, right? So git add, git commit, add formatter for, well, implement formatter for optional class. Push that. Right, so now we can print our optional class. Mind you, I could have just done this for a standard optional, now that I think about it, because like it is public, but oh well. It is cool to make your own class anyway. Right, so then let's go back here. Yep, so now this works, which is nice. And yeah, it works. So again, if I print the output here, so the first one is 3, right? And 3 is at index 0, so it is. The first one is at index 1, correct? The second one, right? So the 1th one, or the second one, if you whatever, that's at index 1, 0, 1, 2, 3, right? And here it says it's 3, so that's correct. Then we have 4 and 5, which are in 2 and 4, respectively. And then we also want to have one that isn't there. So if I print line array.sequential search, let's do like 42, right? 42 is not here anywhere, so that should not error, but that should just return nothing. And likewise, if I do 1, but the third one, or index 2, then I should get nothing as well. Nice, yeah, so they're both empty. Perfect. So git add test cases for empty option for empty sequential search. I don't know why I'm even committing that, to be fair, but whatever. Right. So sequential search works. Then we should like time complexity and stuff, right? So the time complexity of sequential search is O of n. What the hell? The time complexity of this is O of n, yeah. So also the space complexity, is that worth for search algorithms? Like breadth first search, for instance, that's for trees. Like that for that the space complexity is relevant. Maybe other search algorithms might keep track of something. I don't know. But yeah, well, quick comments here. So I do forget how I honestly C++ is like a particular way of doing documentation comments, but I guess I'll just ignore it because I don't really care about that right now. I'll just do this. So algorithm, sequential search. I mean, it's in the name, isn't it? But like, okay. Yeah, so time complexity. Worst case. Well, actually, well, yeah. Start with the worst case is O of n, and best case is O of 1, right? Space complexity is simply O of 1 as well. Because it only stores 2 variables in next iteration. To be fair, maybe I should just put these in the README instead of in the project itself. Right. Actually, I'm gonna leave this here now. I will elaborate in the documentation, but I'll leave these here because they're like low-key useful notes to have. Oh my days. Low-key useful. Okay. But what? Okay, there you go. Useful notes to have. Yep. So let's do another algorithm. Hopefully not binary search. It is binary search. Now, binary search only works if they are in order, right? If I'm not mistaken. Oh, so let's have a look at the pseudocode here. Right, while and found equals false. Jesus Christ. Okay. So let's have a look at binary search. Only when the sequence of numbers is sorted, yeah. So application, okay, so requirements, none. I mean, you have to be able to compare 2 values, but that's like a given, so that's fine. So I'll do special requirements. Nice. So now let's do binary search. So no discard. Auto binary search, auto because it can find nothing, so we'll do optional again. Value type target, and we can't do iteration in this case. Right. Oops. What's the return type there? Optional. Size t for the index. And yeah, so to do binary search, we basically just split the array in half each time, and then we go from there. And the time complexity I think is log of n, because we're dividing by 2 each time, so it's faster than n time, because log of n is faster than that. In fact, I can pull up a chart here, time complexity chart. I do want to get this on my wall, I think it'd be fun. But yeah, O of n is this line. N log of n is there. Sorry, I was wrong. O of n is here, and then O log of n is actually very close to 0. Sorry, very close to O of 1. So it's quite efficient. But worst case scenario, binary search is, well, actually no, it is also O of 1, I guess. Is it? Let's see. So we need to have. It's not. Okay, you can do it recursively, but I won't. Or maybe I'm tripping. No, I'm definitely wrong. Well, I mean, whatever. Anyway, so we're gonna do like this. Value type pointer to the first element. Left bound, right bound? Yeah, that's right. So we have left bound and right bound. What did I just do? Okay, left bound and right bound. Those are both pointers. And then it will half it depending on whether it's higher or lower. So the requirement here is that they need to be ordered. Well, they have to be ordered, which therefore means they can't be compared orderly, whatever. So then we'll do for. Oh, so sorry. Initial values will be array, and this would be array plus size -1. I think that's right. Array is a pointer, by the way. That's which is why that works. If you do plus size, it goes after the array. We want it to be after or before? I actually can't remember now. Let's do. Let me think here. For binary search, the upper bound should be the final element, not past it. Yeah, so we'll do -1. Okay, so then for not even for while. Although it'd be useful to. Well, it'd be useful to return some extra information, like the number of comparisons. Actually, yeah, I should do that. Okay, I'll do that later. But for now, we'll just do while. True. No, while left bound does not equal right bound. That's how we know that we've collided. If we do, then we need to return empty. Otherwise, we need to check. So what we're doing, so we're checking if the middle point is greater than or equal to target. So the middle point would be, okay, we'll create another one here. Value type middle equals array. Well, no, so we'll do left bound plus right bound. Left bound plus right bound minus left bound over 2. Now, okay, so for pointer arithmetic, this will give me the left bound. I'm adding the point to the address of this. So that would just give me the right bound. But I'm dividing by 2. That should work. So that should give me the midpoint, which is fine. And then let's actually put it here. Okay. So we have the middle. Then we're saying if middle dereferenced is greater than my target, then we're going to, so that means like we're too big. So the right bound needs to shrink. So right bound equals middle. Else if the middle is less. Okay, hold on. First things first, if they're equal, then just say you found it, right? Let me simplify this, because this is actually way too complicated. Let's just do 0. We'll do left bound. We'll use size t's instead of pointers. Well, we'll just do index based, because that's a lot easier. Plus size t, well, it's always going to be 64 bits, but whatever. So right bound equals size minus 1. Okay. And then same thing here, that's fine. And then the middle will simply be a size t as well. CIW, size t. Make sure my face isn't covering my inputs here, right? Are they? No, they're not, okay. Sorry, middle equals, yeah, left bound plus right bound minus left bound over 2. Yeah, so left bound, I mean, here it's 0, so this is 0, but if it was different, then you need to offset it. So here, let's say I have an array of size 8, right? So my left bound would be, yeah, sorry. So my left bound would be 0 plus, well, just 8 over 2, so then my middle would be 4. So 0, 1, 2, 3, 4 is the middle. And then that's that. Now, obviously, it's not the perfect middle, but it's fine. Whoopsie daisy, just banged my camera off. If it's 9, which has a true middle, then it would be 9 divided by 2, which is 4.5, and I get 4 again, because it rounds down. So if I get 4, then 0, 1, 2, 3, 4, 5, 6. 7, 8, 5, 6, 8, 0, 1, 2, 3. Yeah, that's fine. So that is a true middle. So then that's fine. So we say if array middle. So yeah. So at that position, if it's more than target, then we set the right bound to the middle. Otherwise, we set it's otherwise. Now let me just get here value type by reference. Well, I guess you might as well just copy it. Well, no, because actually it could be bigger than int. So we'll take value type by reference. Current value, let's say, equals array at the middle position. Right? We're going to reference that. And then we're going to say if current value is greater than target. But first of all, actually, if current value equals the target. Now, the order here does technically matter, but I wonder how it will play an impact. I don't know. So if it equals that, actually, because they shrink, no, we're comparing. So if it's equal to it, then we return middle. Yep. Else, I mean, I don't really need an else here, but whatever. Else if current value is greater than target, then that equals middle. Else if current value is less than target, then left bound equals middle. Now, this final else if isn't necessary, but we'll just put it there anyway. In fact, let me, yeah, okay, fine, I'll do this. Right, so that works. And then just keeps going. And that should work, I think. Let's go back. Right, so this is sequential search. I want to store this in a function so I can like call it. So we're gonna so we're gonna do standard print line. for a usage guide. So usage, if you do, okay, int argc char argv. These are the command line arguments. So if you call it with certain arguments, they'll be different. Actually, no. No, I'll do runtime. So let's do. I will need IO stream for this. Okay. So print line. Enter thing to test. Enter algorithm to test. Yeah. Current options are, and I mean, just for now, I'll make it simple. So we'll have array, search sequential, and array search binary. I will like flesh this out more later, so that works whatever. But anyways, we'll do that, and then give these little thingies. Okay, so then we'll do standard cin for the input, user inputs, store into there. Actually, you have to do standard get line of standard in to start user input. There we go. And then we'll do if user inputs equals array search sequential, then do this. Yep, so array equals boom. Yep. So array index of 3 equals this, index of 1 equals this, index of second one equals this, index of 4 equals this, index of 5 equals this, index of 42 equals this, index of second one equals this. That's first one, sorry. No, this is second one. This is first one. This is third one. I need to flesh this out more anyway, but whatever. So then else if user input equals array search binary, then we're gonna have a static array again of int 5, let's say. Well, let's do 9. Now it does need to be in order. So we'll do array equals some random values. Screw it. So 2, 17, 23, 42, 96, 100 and 206, 5, 283, 4, I guess, or 3, 1, 2, 3, 4, 5, 6, 7, 380, 96, 396, 1, 2, 3, 4, 5, 6, 7, 8, one more, 409, 402, 409, what? For a 4. That's what I'm thinking of. Error 404. Okay. Then we'll print that. Array equals array. And yep. Index of, let's do 23 equals this. Array dot binary search. See if that is correct. So let's do build. What? CMake build. Cannot convert. Whoops. What? Binding reference of type to static array discards qualifiers. Uh-oh, this again. Wait, so array access is not const? What? That can't be right. Because of this. Okay, then we'll do copy, that's fine. Right? Should make a difference. I mean, it does because of copy, but I guess I have no choice. It works, so let's then, well, I mean, it compiles, so let's do that. So first let's test sequential. Yeah, that works. Maybe let's just expand this. Okay, that works. Hold on. Okay. Some just formatting conveniences here. Make reading it a bit easier. Right, so let's compile, build, compile, whatever. No matching function call to standard print line. Okay. Right, so array search sequential first of all. Looks like to work. Looks like it works. Yeah, it's just a bit funky there with the whatever. And then let's do binary and see if that works. I fully expect it to not work, but we'll see anyway. Array search binary. Oh, okay. So that's at index 2. So that appears to work. Okay. Let me try this. Let me do for auto element in array. We're going to standard print line index of that. See if it gets the all the indices correct. Good way to just test all of them. I just CMake first, please. What? What's wrong? Oh, I can't for over my array because I need to define start and end. Okay, I'll do that later. For now, let's just do array like this. Let's cheat. Nice, and then build. So array search binary. Right. So 404 doesn't work, but it does work for all the other ones. It's just the last one where it breaks, and I wonder why that is. Probably because of a rounding error. Yeah, it definitely is actually. So if you go to control here, so this will round down, which means it'll never reach. Yeah, so it means that it the right bound, like here, see how it says left bound equals middle. The middle will always, like if there are 9 elements, the middle will always be 8, because the middle would be 8.5, and then it would round down to 8, and it'd be stuck at 8. So I could fix this technically, but there's a way to get around it. I forgot what it is. If I ceiling this, I get the same issue. I don't really want to conditionally round up and down either. But like there is a way to do it. I remember I was stuck on this in Java as well. Mama, I am. What? But that for some, like, you know people get that like stuck in your head. Get songs stuck in their head. For some reason, I have this video of the child saying, where the mother says, "Are you having fun?" and the father says, "No," and then the child in his lap says, "I am, Mama, I am." So I had to share that because it's stuck in my mind. Left bound, like right bound, or I can't do like the size is also off. I forgot. Let's just look at the implementation here. Floor. Okay, that happens anyway. Find equals true. Last equals middle minus 1. First is mid plus 1. Okay. Test first, ask questions later. Because if it doesn't work, then that would just waste my time. Okay. Okay. Array search binary. It doesn't work. What? Who'd have thought? Okay, so hold on. If a middle equals key, return. If it's more than, then minus 1. Less than, plus 1. While first is less than or equal to last. Interesting. I think that there are multiple ways to implement this. But let me see if I can like wrap my head around this. Again, array search binary. I should have done numbers, bro. Yeah, so that works. Okay, so let us see here. So let's say we have 9 again. It will go through the middle, so 96 is the middle. We're looking for, let's say we're looking for 404, the highest one. It will say, okay, then go to the left bound. We already know it's not 96, so we'll just move it to 205 instead for the left bound. So then the middle becomes 283. is still less than, so then we do plus again, so just do 396 and 404. The middle would be 396, that's wrong, so then we just do 404, and that is correct because that's 404. On the other side, if we do 2, we get 23. Well, no, so 96, yeah? Then minus 1 to 42. So then we actually get 17. And then, once again, that's too high. So then we set the lower bound to half of that, which is just 2. And that returns. Okay. I'm trying to think, when does this less than or equal to come into play? So let me change this back. And see which ones get triggered. Oh, 2 does get triggered. That's interesting. I wonder why? While left bound does not equal. While left bound is less than or equal to. Which means not more than. Not more than. So it can be equal, it can be less, but it can't be equal. It can't be greater than. Okay. Because why? Oh, whoops, that's falling. Because if it's less than, then I guess it can just keep shrinking. If it's equal to, then it will find the value anyway. If it's greater than, then nothing's found, because we're dividing by 2 and taking the floor of it, right? So if I try to search for like 500 instead, what would happen? It would blow up. So it would go from here, then check this here. It would say still too small, so then it would set the midpoint to this. Too small, so then it would take the midpoint of 404 to itself. But that's still too small. No, I think I'm wrong. 96 to here. No, so then here to here. No, so then here to here. No, so then here to here. At this point we have 7 and 8, right? So 7 plus 8 is 15, divided by 2 is 7.5, so we get 7 again. So then we're stuck here, which is less than, so left bound is less than right bound in this case. No, wait, it's plus 1. So it'll be 7.5 plus 1, so it'll be 8. So we have this, and they're equal, but still not correct. So then it'll go plus 1 again to 9, at which point left bound has exceeded the right bound. Okay. So that's why we do less than or equal to. Which means like not greater than. But also, it's interesting because it can't happen the other way around. Like the right bound exceeding the left bound is not. It's just not a consideration, I guess. And I'm guessing that's because it rounds down. So if I do, let's do like -5 in this case then. If I do -5, I have this. Then it goes, okay, fine. Then between this and this. Yep. And then it says, okay, between this and this. So I get 0 plus 1 divided by 2. 0. Minus 1 is -1. So now my left bound is -1. And my right bound is still 17. That is dodgy. Let me. Okay, let's add like whatever case. Yeah, what do we call this? An edge case. Check. Of index of -5, right? And we'll also do. Well, we'll do a few. We'll do that one. We'll do 500. And we'll also do 25, which is within the range, but not actually in the array. Array search binary. Yeah, we got a segmentation fault, which is what I expected to happen. Could it be because in Java negative indices wrap around? Maybe. In which case it would exceed. That would make, well, this is pseudocode though. It says that this will trip it. That might just be assuming that it wraps around. I can't think of why else that would work. So let's also do and left bound cannot exceed right bound, and right bound cannot exceed left bound. So it has to be greater or equal to left bound. I still get a segmentation fault. I'm not understanding what's wrong here. Okay, let me again ask Claude. What's wrong with this algorithm? I get a segmentation fault for some edge cases, let's say. Fuck's sake, man. Wrong one. Oh yeah, it's unsigned, so it wraps around. So the keys are not -1. Yeah, I thought it didn't make sense to -1. Exclusive upper bound. Okay. Right. Yeah, because if the size is 0, then it'll just overflow or whatever. Not overflow. It would access 1, which doesn't exist. -1, sorry, -1, which doesn't exist. Mind you, left bound equals 0. No, that should be caught. So I think that's fine actually. Like this would immediately return empty, and then this is just less than or equal to, because we're removing this. Yeah. So why is it here? I don't get subtracting 1 if it's already rounding down. Like, this just doesn't even work. I mean, it's pseudocode, but like, still, like, the assumption should be. Oh my god, it's because this is fucking index based on 1, isn't it, bro? Okay, what now? What? How did that even happen? Okay. Right. Compiles. Okay, so this doesn't work for the last case. If I move this, it'll work. Or change this to equals. Well, less than or equals. Would that also make it work? Question is, which one is more correct? No, that one just goes infinite loop. Okay. Right, so this is the working version then. So the question is, how does this work? I mean, this one's simple. It just iterates through. For this one, like, why are we overflowing? Right, so that does remove the need for subtraction. And we change the termination condition, yeah. Interesting. So what's with this code? My code does not use floor, but okay. So it's fine for pseudocode. Right, yeah, so it is because this is 1 indexed. Fuck that, man. It's so annoying. Okay, let me just change this real quick. Left bound should be upper bound, and lower bound, sorry, and right bound should be upper bound. Okay. So yeah. Yeah, I don't feel like it's worth adding comments that literally just describe C++ behavior that you're kind of expected to know as a C++ developer. I don't care about that. Okay. So like it's so simple in concept, but like the implementation is quite difficult to wrap my head around. Anyway, it is what it is. So let's go ahead and add the information then for this one. This is binary search, ordered elements, or ordered, yeah, it's ordered. Worst case scenario, it's log of n. Best case of 1, of course, and space is just again of 1. Yeah. That is correct. Well, O log of n plus 1, but we ignore that. Okay. That's pretty cool. Is that right? Nah, I'll use braces. Parentheses, whatever. Yeah, so that's cool. It works. Let's run it one more time for good measure. Yep. So git add, git commit, implement binary search for static array, and push. If I create a dynamic array, I guess at that point it would make sense to create an array class and then derive from it. Like derive like an array abstract class, just so that I can have sequential search and binary search work for both. Right? Because they're both arrays. Although at that point I might as well make a Anyway. So that works. I now have sequential search and binary search. And those are the only search algorithms I have for arrays. I mean, what else do you do, right? Bogo search. Should I implement bogo search? Fuck it. I'm gonna implement bogo search to finish this off for today. So size t. No what? So I need the random library here. So C++ random number generator. There is C standard lib, but is it not like a C++ way to do it? Like standard rand or something? Yeah, it's so fucked. Okay, calling this simple is devilish. To be fair, it isn't even that like complicated. It's just the verbosity of standard chrono duration cast of standard chrono seconds to standard chrono system clock now time since epoch dot count plus the we're casting to a standard MT19937 result type for a standard chrono duration cast in standard chrono microsecond for the standard chrono high resolution clock dot now dot time since epoch dot count. Like, Jesus. Okay. What is the simplest way to generate a random number between a range in C++ idiomatically, whatever? Okay. So okay. Good random QRS, and we use MT19937. Why can't I just add like a generate random number function? Like I get like. Actually no, I don't get it, but whatever. Like it'd just be a bit convenient, you know. If this is the way to go about it anyway. So we create a static for the lifetime of the program, seed, right? Or whatever, I guess. Okay. Standard random device. And then a standard uniform int distribution dist for min max. Whoops. The minimum will be 0. The maximum will be the size -1. And then for, well, while true, What if I want a size t? Oh, okay. Sick. Yep, so standard size t, index equals, well, just dist RNG. If array index equals target, then return index. And that's it. Then they'll just keep on looking forever. And if it doesn't find it, then it just quits. Now, if you run this, you have to make sure target's actually inside, because otherwise it will just never not return. Like, I could set a hard limit, but that'll kind of defeat the purpose of bogo search. So we'll just do this. It's a while loop. If it never finds it, it never terminates, and that's kind of your fault. So let's go here then. Array search bogo. User input equals array search bogo. So okay, StaticArray. I don't know. 3.14159 3.15926535897 Let's stop there. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. We'll print that array. And then, ooh, there are multiple different instances of it though. So okay, so it can't tell you which is which. That's, I guess, a flaw. So let's change these numbers up. 3.1 23, 5, 9, 2, 6, 42, 3, 108, 8, 902, 7, 85. I think that's no duplicates. 3, 305, 369. Okay. And then let's do a search. So standard print line, index of 369 equals, and then array.bogo search 369. So we're going to compile. Took a while. And then we're going to build array search bogo. It found it in record time. So the idea here is that the more times I do it, the longer it will take. Oh, sorry, it's like the time it takes can vary. Now, I do need like some bigger arrays, to be fair, but I'll do that later, I guess. Anyway, clear git add, git commit, implement bogo search for StaticArray, bogo search, push, and I'm going to leave it there for today. Let's just quit. Delete this one. Right. Nice. So the next thing to do would be to first of all generate documentation. That's quite important. Second of all, do like proper test conditions, like set up the application properly so I can like really test things properly. Also, the functions need to also return the number of iterations, the number of comparisons and the time taken. So if we look at some of these other things, so like let's do I don't know, algorithms. Like algorithms simulation. Ooh, what the hell? Have a look at that. Yeah, this one. So it has a keeps track of comparisons and it keeps tracks of array accesses. Right. Anyway, so yeah, so each function should return the number of comparisons, and I can return the number of array accesses. I don't know how important that is, to be fair. I mean that's more for sorting, right? I will like look into why this matters. But if it does, then I'll also do array accesses. So those need to be returned from the function directly, as like in a structure or whatever, and then the sorry, just my brain's shutting down. And then I can benchmark for time customly. Like I can just like you would check how long it takes outside of the function, because that's fine. But then I'll also set that up so I can also check how long it takes in milliseconds. And then I would check like longer arrays and stuff, and so on and so forth. Have like a random array generator set up, and yeah, should be good, right? So yeah, 3 hours, made quite a decent amount of progress. I don't know if I understand the algorithms better. I mean, it's just, I mean, I've only done 3, one of which is not in our course, but I mean, yeah, I mean, freaking sequential search is very simple. Binary search, it was good to review that. It always is. I'll see if I can keep this in mind for the exam. And then like really like the time complexity is also important. Like remembering why and that. That and why binary search is log of n, right? For the worst case scenario. And like here, this one's O of n. And then when I get to this is fairly simple. The sorting algorithms will be the main thing. To focus on. What else even is there? I have min max, well, finding the max / minimum, 2D arrays, doesn't matter, queues and stacks, and okay, so those are these are data structures, 2D arrays, queues and stacks, linked lists. I will get to those. Then sorting algorithms like bubble sort, selection sort, insertion sort, those will be good to review. Then I need to create trees and graphs. So I'll see how I can implement those. Binary trees are interesting because you do use them for like Like I kind of did it for my calculator in C++, although I don't remember how far I got with it. But yeah, graphs as well. And then I can do algorithms like that, like greedy algorithm, divide and conquer algorithms, like binary search. I think that's a thing on trees as well, and also dynamic programming. So memorization would be cool. It would be very cool to do that. It would be very cool to do that. Hopefully, I can get that far before my exam starts. Otherwise, I might do it anyway, because like I think this content will come up anyway in future modules. So like next year. So that's fine. But yeah, but also like depth first search, breadth first search, stuff like A* search, and greedy search is here, there, and whatnot. Anyway, so yeah, I will continue with that either later today, later tonight, or tomorrow. Yeah, no, I won't do it today because I need to focus on my other modules as well. Before that though, let's just watch this other video. So this is A* search. Is this what Google Maps does? God damn. That's crazy. And that would be the shortest path, right? Yeah, no, this is a real place. That's crazy. So a computer will calculate this when you run Google Maps. Although I assume it will cache some things in its database for hot routes. Wow. Okay, what I find interesting is that it spreads out towards the goal as opposed to in a circle, and I guess that's because there's a heuristic, right? So first of all, the question is how does it calculate the heuristic to know the distance, how close it is? But yeah, I guess that would help it. Whereas if you just did what's it called? You greedy search, A* search, and some other one. That one would probably just go in a circle because it ignores heuristics. That's cool. Lightning does the same thing with electrons. Does it actually? I mean, it looks very lightning-ish, doesn't it? Lightning follows the path of least resistance. That's actually very interesting. Anyway, yeah, so that's that. So yeah, good revision-ish so far. Not really, but as I keep going, it will be very good. So yeah, obviously quite time-consuming, but it's fun, so I don't care. Yeah, subscribe.